Hello, in this video, I am going to highlight some important basics of Booth's multiplication algorithm. We should understand commonly arising doubts such as how many bits are to be used for multiplicand, multiplier, and product, and how to handle signed numbers in Booth's multiplication. Booth's algorithm is used to multiply two binary numbers. So, if decimal or hexadecimal or octal numbers are to be multiplied, first they must be converted into binary numbers. These numbers are also called as binary coded numbers. Let B be the multiplicand and Q be the multiplier. While binary coding B and Q use the same number of bits for both B and Q because the same size of registers will be used for both. For example, if we want to multiply 6 by 3, the multiplicand 6 is coded into binary as 110 and 3 is coded as 11. So you add a leading 0 to 3, which is now 0, 1, 1. Add an extra 0 to the left of the binary coded B and Q. This bit is used for handling the sign. But remember that irrespective of whether the number is positive or negative, you should add only 0 because it is not the actual sign bit. It is only used to handle the sign. If the number is negative, take 2's complement of that number. If the number is positive, you need not take 2's complement. If you coded 3 as 0, 1, 1, and if it is plus 3, leave as it is. And if it is minus 3, then take 2's complement of 0, 1, 1. The 2's complement of 0, 1, 1 is 1, 0, 0 plus 1. And it is 1, 0, 1, where 1, 0, 0 is 1's complement of 0, 1, 1. In Booth's algorithm, only binary coded multiplier is recoded using Booth's recoding table shown here. Before recoding the multiplier, add an extra 0 to the right of the multiplier and it is called implied 0. If I is the bit to be recoded, then I minus 1 is the bit right to I. If I is 0 and I minus 1 is 0, then I is recorded as 0. If I is 0 and I minus 1 is 1, then bit I is recorded as plus 1. If I is 1 and I minus 1 is 0, then the bit 1 is recorded as minus 1. If I is 1 and I minus 1 is 1, then the bit I, that is 1, is recorded as 0. Consider the example minus 6 into 3. The binary representation of multiplier 3 is 1, 1, and for plus 6 it is 110. Since the multiplicand has 3 bits, let the multiplier be represented with the same number of bits by placing zeros at the left. Now 3 is 0, 1, 1. Remember that adding leading zeros like this will not change the result. It is done based on the hardware perspective. Now add an extra 0 to the left of the multiplier to handle the sign. Now the multiplier is 0, 0, 1, 1. To recode this multiplier, add a 0 at the rightmost position. Now this bit is to be recoded. So this is the ith bit and I minus 1th bit is 0 now. So use the table. The ith bit is 1, I minus 1 bit is 0. So it is to be recorded as minus 1. Now you consider this bit. The ith bit is 1 and I minus 1 bit is also 1. So 1 means it should be recorded as 0. Similarly, to recode this bit, third bit, this is the ith bit, this is I minus 1 bit. So 0, 1. So it should be decoded as plus 1. Now you consider these two, it will be recorded as 0. So if you put many zeros in the left side, there will not be any effect after this, because after this all will be 0 only. So this is the final recorded multiplier. Now let us see another example, 13 into minus 6. Here the multiplier is negative. The multiplicand 13 is represented with 4 bits. So we represent plus 6 also using 4 bits. So plus 6 is represented by 0, 1, 1, 0. Now add an extra 0 to the left of the multiplier to handle sign. Now the multiplier is 0, 0, 1, 0. You be cautious, don't add 1 to represent a negative number. Here, negative numbers are represented by its 2's complement. So take 2's complement of the multiplier along with added 0. So for that, first you take 1's complement of this 0, 0, 1, 1, 0, and it will be 1, 1, 0, 0, 1, 1. Now add 1 and you will get 2's complement as 1, 1, 0, 1, 0. Now recode this multiplier. For that, add a 0 to the right of that number. Now the 0, 0 will be recorded as 0. Now this bit is combined with this 1. So 1, 0 will be recorded as minus 1. Then 0, 1 will be recorded as plus 1. Then 1, 0 will be recorded as minus 1. Then 1, 1 will be recorded as 0. So the recorded value is 0, minus 1, plus 1, minus 1, 0. But anyway, the leading zeros will not have any effect in the multiplication.